This is a Fender Bassman AB165 Blackface amplifier built in 1967. Our goal today is to replace the 6 electrolytic filter capacitors in the B+ power supply and the 50-volt electrolytic in the bias supply. Although this amplifier was built in 1967, it is of a CBS design. All the capacitors, with the exception of the bias capacitor, are mounted under a shield can located next to the output transformer on top of the chassis. The filter section of the B+ rail consists of two 40 microfarad caps in series, parallel to the secondary winding of the output transformer. The second stage is made up of the one choke TR2. The third stage is a tank circuit consisting of two parallel 20 microfarad caps and a 4.7K dropping resistor. Finally, there is an 8 microfarad cap to provide filtering for the front end. Once the capacitors are exposed, you'll want to check for voltage present across them. Test each cap independently. If the power supply is properly loaded and everything in the amp is functioning, there should be a reading of approximately 0 volts. However, I have seen cases where tube amps, having been stored for 20 or 30 years, have still had substantial voltage present on the filter caps. This is a 525 volt power supply, and it is a shock hazard, so be careful. The caps are held on a plate made of 2 sheets of fiberboard phenolic. 2 Phillips screws secure those fiberboard sheets. You will need to remove them and lift the top sheet, exposing its underside. The caps are hardwired into the circuit using steel bus wire. I generally will place a screwdriver across each of them for a second to ensure that they are indeed discharged. I find it more convenient to actually work backwards here. I start with the 8 microfarad preamp stage cap and work from left to right, finishing with the 2 primary capacitors. For desoldering from these eyelets, I use a Denon SC7000Z desoldering tool. Before I replace the cap, I like to use a ground continuity test to help assure myself of the polarity of the capacitors in circuit. We know that all but the 2 primaries share a common ground, so by doing this test, we can rest assured that we're not installing one backwards. Those of you who have worked with electrolytics before are aware of how important polarity is with them. Once that's done, I simply insert the replacement capacitor and solder it in. Don't forget to resolder in the lead that goes back to the circuit board underneath the chassis. These amplifiers had notoriously weak filter stages in their power supplies. A common modification is to add a parallel stage of filtering by installing a series of 100 microfarad electrolytics underneath the chassis. This will improve low-frequency punchiness and will help reduce hum. However, I would not recommend this mod without first replacing the old rectifier diodes with 1N4001s or better. Those old diodes can't take the surge when working into uncharged capacitors of that size. The remaining caps on the board, besides the primaries, are straightforward. Remove and replace them the same way. Make a note of how they are bus wired on the bottom side of the phenolic. You will need to redo that wiring. If you're working from the layout diagram, you won't be able to see the capacitors, as they are not shown. All you will be able to make out is the point where the wiring harness goes up through the large eyelet cut into the chassis. Here is a close-up of the tank circuit that provides filtering for the second gain stage and the critically sensitive phase inverter parts of this circuit. This particular phase inverter relies heavily on its power supply to maintain signal balance. In this final view of the amplifier power supply, you can see the 8 microfarad capacitor that's used to provide filtering for the preamp stage. Finally, we come to the bias supply capacitor, a 50 microfarad 50 volt electrolytic. Because the output here is negative, the capacitor is installed with its positive plate at ground. Do not forget to pay attention to this polarity. The cap is located on another double fiberboard phenolic, which is under the chassis directly above the power supply transformer. This board also holds the rectifier diode. You will want to perform the following voltage tests when you're done. First, measure the DC output at the rectifier diodes and ensure that you're getting 525 volts. Then, switch your meter to measure AC and check the ripple voltage. This is a stiff supply and the AC component shouldn't be any more than 5 volts. Next, check the voltage present at the bias diode. It should read negative 45 volts. Finally, check the bias on the grids of the individual output tubes and adjust for a match. The bias circuit on this amp has two inherent weaknesses that make it difficult to set. First, it's grid bias rather than cathode bias, and second, one tube is fixed, whereas the other is variable. Your goal is to adjust the variable tube to match the fixed tube.